Good morning, everyone. Can you all hear me in the back? Good? All right, let's get started. Today, we're going to be talking about vibe coding versus context engineering versus spec-driven development. My name is Ron Dagdag, and I am a research engineering manager at Thomson Reuters. I used to work for 7-Eleven. I just recently changed jobs. And also, I'm a Microsoft AI MVP. Been a Microsoft MVP since 2017. This is my mantra. I code, create, coach, and repeat. I code because I enjoy the engineering work. And I create spaces where we can experiment. I consider myself a scientist to try out different things and new technologies and learn more about these new technologies. I coach, and that's one of the reasons why I'm here today, because I want to teach you what I've learned. And of course, as a manager, also helping other engineers to become better at what they do. And then repeat. Find another set of technology, code and create, and then coach, and then repeat. With the show of hands, a lot of us here are on level 0, coding by hand, right? You raise your hand if you're a coder, right? If you've been doing engineering work and doing coding by hand. Then there's level 1. This is our AI adoption hierarchy. Level 1 is autocomplete. A lot of the Visual Studio Code, a lot of the coding tools have autocomplete and AI-enabled in IDE. And then there's level 2, which is a single shot in what we call vibe coding. Has anyone have used vibe coding before? A little bit, so they're trying to understand about half the room. And then there's level 3, which is conversational, which is what we're going to be talking about a little bit today, which is context engineering. And then level 4 is plan-driven, which is spec-driven development, and then autonomous. So these are some of the adoptions as you go through as your AI coding journey and how you adopt AI in your everyday. All right. So there are 4 approaches we're going to talk about today. We talked about vibe coding, which is fast, intuitive. Then we do context engineering, which is making it more informed. The AI become more informed. And then we have spec-driven development, which helps you create specs. And we've attended last presentation. We talked about a little bit about spec-driven. And then moving towards some agentic, event-driven coding agents. We'll discuss more about that. So think about this as a GPS analogy, right? Vibe coding would be like, hey, AI, take me somewhere nice. What does nice mean, right? It could be a nice restaurant, or it could be a nice parking lot, right? Context engineering is more towards, you ask AI, I want to go downtown, avoid highways, I like Italian. You'll have good options, right? Mostly, you might get it right. On spec-driven, you specify the address, where you need to go, what time, no tolls, exact destination, verified, and it is repeatable. So when you're going through this, I also want to do a little bit of demo on, just our demo app called VoteJam, a little bit, to kind of help us understand this technology. So our journey today, we're going to talk about vibe coding, context engineering, spec-driven, a little bit about event-driven coding agents, and then playbook. Okay, let's start with vibe coding. So what is vibe coding? It's more of conversational prompts. If you go use the Visual Studio Code, there's GitHub Copilot that's already installed. You can use it to describe, but you don't specify. You do rapid iteration, minimal upfront planning, and has broad freedom to interpret what you're trying to do. So you describe it by using natural language. There's a lot of vibe coding tools that are available out there. Like I said, Visual Studio Code has part of GitHub Copilot, but there's Lovable, V0, and all these different ones. Even Claude had Claude artifacts today I'm going to show a little bit about Lovable. So let's do a little bit of demo, what that looks like. I have something that's recorded here. So I have a prompt. I specified, build me, some text, UI, and it starts working through that whole process, right? So it's installing some of the front end, index.css. It's building some context. It's TXT files. Of course, it takes quite some time to kind of build the application, but at the end of the day, let's see if I can forward it towards that. And go through. And has anyone have tried this before, where it's going to start building the app and visualize it? So these are some of the tools that you can use for vibe coding, right? So you can build the UI really fast. And you can build multiple times on how you would do this, right, for different projects. It starts building the code based on that. With just one prompt, it built this UI. And of course, it's AI generated when it's like purplish type color, because for some reason, AI thinks that's the best color in the world, right? It's a little bit purple, reddish color, right? So that is vibe coding. What I recommend whenever you're doing vibe coding, there's this AIM framework breakdown, right? First thing you do, you specify what is the actor or the persona. Define what do you want to be the AI to be, right? The expert marketing consultant or senior Python developer. You specify the actor. And then you specify the input, which is more bringing in context. If you can provide some other information about background data, constraints, examples, you bring in a little bit more of the context, and then the mission, what you want it to do. Define what the AI should do as an input. Like for example, draft 500 words for this blog post, refactor. So all these, step by step. You specify the persona, you specify which the actor, the input, and then the mission of how you want it to accomplish. And some tips related to this is more, start with your intent, right? Not the implementation. Iterate in small bursts. And if you can provide screenshots too, right? As part of the UI reference. So let's say there's an error message, rather than typing in, capture that image, paste it on the prompt itself as part of the input. And of course, slow down. Sometimes AI can generate fast enough that you want to understand what changes can happen. Okay. So when should you use vibe coding? Vibe coding, if you have something that you're prototyping, some spikes, you're learning some of the new tools, you want to learn about the code base itself, sometimes you use it for throwaway scripts. If you're doing a lot of creative exploration about how you want to do it. But if you have something that's security sensitive, long-lived code base, anything that needs code review, I recommend moving forward into another set, which is our next piece, which is more of context engineering. The goal is to give the AI the right information at the right time as needed. So what is context engineering? Context engineering is designing the information, the environment around what it would produce, right? So you feed it with the documentation, some of the style guides. You set some tools, permissions, constraints. If you hear about MCP, if you hear about skills, and all these different terminologies that came out in the last 5 months, a year or so, there are some. The goal is all related to bringing in more context to how you would run these AI agents. In terms of the output quality, AI output quality, your prompt usually is just, it's kind of like an iceberg, right? So the topmost is your prompt, but AI needs more information, and what actually determines the best output of it. One is context files. Some of them are schema, examples on what you can provide, constraints, formal specs. A lot of those things helps to produce better output code quality. And inside that context window, there's a lot more things that the AI cannot see, right? Even though you included on your prompt, your agent's MD or some markdown files, some screenshots, or some code examples, there are some things that are not visible to the AI. One is the Git history, or the architectural documents outside of the code base, right? The design decisions within the team, you work with the product management, and the implicit conventions within the company or within the team, and then of course other bug fixes. So there are things that's outside that it cannot see. But at the same time, we wanted to provide as much as context towards one thing is more, how do you make sure that you're providing the correct data? Another one is it complete information? Does it have everything that it needs? Some of the rules, some examples. And of course, there's also each one of these, every time you specify or call the AI, there's context window that sometimes too much is not good. Sometimes it's too small is not good either. So there's sometimes it can be noisy or some gaps in between. And then there's the trajectory, like where is the conversation going? Have you ever, when you're doing some vibe coding or you're going through a step-by-step, and then it's going nowhere, some of the conversations going nowhere. That can happen too. So those are the things that we wanted to make sure we optimize as part of our context window. So, like what we mentioned, think about it as this analogy. It's like a new hire, right? Like a new intern every hour. Day one, right? If you're going to hire a person, day one, if there's no onboarding, you give them a ticket, go build it. They don't know what they're supposed to do, right? So it would miss some of the rules, some of the framework that is needed, and code review would be painful for the team. But if you have something that you have an onboarding packet for a new hire, that you have the style guide, you have the naming convention, the patterns, the rules, some of code review would be easier, it would be better. It's not by line. Either you still need to do code reviews, but it would help out. So 3-phase on this agent workflow on how you would do context engineering. One is research. Research means reading the code base, schemas, everything that it needs, and then some planning phase, where you specify the design approach, what are the files that needs to change, some instructions you need to do, and then the implementation phase. So research, planning, and then the implementation. In order to provide more context, we talked a little bit about the document standards, the schema types, some of the permissions, and some of the examples on how you provide inside the context in order to help it. There are some multiple context engineering tools that are available out there. A lot of them are integrated with your IDE. You've heard of Cursor, Claude Code, Anti-Gravity. GitHub Copilot is one I'm going to demo a little bit today. But there's a lot of tools out there that you can start using for this. So a little bit about context engineering. I don't know if that might be. Okay, so for this one, maybe I can show a little bit what this looks like. Did it? Okay. Maybe not. Then it did not show up. Can't move the mouse. Oh, there you go. Okay. What about this? So I have, see that at workspace on the right side? What it's trying to do is you're asking the workspace to identify like, okay, I'm going to create this code. And notice how it's looking at all the other files that are around this, code base. I also created the skill, when you hear about this skill, which specifies, if you think about it, it's kind of like a recipe for or extra instructions that can be called by the agent itself, right? Be able to identify like step-by-step instructions on how to implement something. So for example, in this case, I'm creating a backend for these posts, and then it'll ask some questions, execute some code, and follow the instructions based from that skill. There's also other ways on how you can, as it goes through and try to understand the other areas, notice how it's creating step-by-step instructions too, right? So because there's a to-do list where you can specify, where it specifies, okay, this install the Express, create vote repo, then add voting endpoint. So it goes through each one of these. So if you think about on the context engineering side, the code base and the .github folder that is on the left side, where we specify the skills and then the Copilot instructions, some of those markdowns are being used by the agent as a context to bring in some information to help out build the code. Okay, so it'll go through and understand, the rest of the code base that way. So, and of course, it's showing you the differences of like, okay, based from that agent changing, it would identify like, okay, what are the different files that were changed? What are the different, and also it created types, tests, and all the other things that you would need. So some context engineering tips. Your window, which is your working memory, which is your context, treat it kind of like a RAM. Identify what it's in it that matters. So what do you attach? What are the different things that you can incorporate within the code base? Of course, show, don't tell, don't just tell. That's another one. You have your input and output examples as part of that skills markdown. And then there's, front load some of the critical paths, facts, some information that you can use structured delimiters, summarize prior turns. And as we move on towards our next phase, we'll talk more about this spec-driven development. Spec-driven development is more of contracts, checklists, and enforced pipeline. So what is it? It's you're specifying the specs of what it is. So has anyone here, bought a home or rented an apartment, right? When you rent an apartment, there's this contract that you need to sign before you even get to the house. So think about it that way. What is that contract, right? What is that specs? Before you execute, meaning before you get into the house. So you specified what is the boundaries between, what is the specs, where you specified the contract before you write the code. Humans review the specs, but not every line of code. So the goal here is making it more traceable. So why, in terms of code reviews, why are we doing code reviews? Is it just for style? Is it just to find bugs? At the end of the day, the most common one, why we're doing code reviews, is because of mental alignment. the question is, does the reviewer understand what's going on and what is the goal of these code review? And I know code review because it can be a bottleneck, because if AI generates a lot of code, how do you ensure that we can have the correct alignment between that? So there's that hidden bottleneck on code reviews if we have these AI agents generating a lot of code. So for vibe coding, code review is a little bit more painful. Context engineering, a little bit better. But for spec-driven development, it's becoming shorter. The reason why is because we write of spec. In terms of division of labor, human excels at defining the requirements, setting the constraints, reviewing the compliance, and then AI excels at different ways, right? Generating the boilerplate, the plumbing, what are the known patterns, writing test cases. That's the best use of these AI tools. And then handling repetitive transformation. What are the different, a lot of the boring stuff sometimes. So what is a good anatomy of a good spec? A good spec requires you to specify what is the contract, what is the acceptance criteria for that spec, what are different constraints to look at, security rules, what are the compliance requirements around that spec. And then also explicitly, specifying what it's not supposed to build, so non-goals. And and of course, being able to specify the scope creep, and then the testing scenario. For me, the important part is ability to identify the test scenarios and writing the spec as part of that. There are multiple spec-driven tools that are available out there. I'm going to show a little bit about Spec Kit, which is that can be integrated with Copilot, also integrated with Claude, with other AI tools. There's also BMAD, Cogen, Devin, and a lot of these spec-driven tools. So a spec-driven pipeline. There's 5 steps in how you would do this. First is write the spec. What are the interfaces, the constraints, and all that? Then generate the task around that spec, and then then you can go to the implementation. Once you have the implementation, then you run the test, and then review it again, and then go back, write another spec, and all that. So there's specific steps to go in. For Spec Kit, a little bit about this. Spec Kit goes through these phases, kind of the same as this previous one. One is the constitution, define the project rules, what are the guardrails. You start there. It's optional. Usually what I put on the constitution is specifying, and this is for all the specs that is going to generate it later on. Constitution, I usually specify there, hey, I want to do red, green, test-driven development for this, right? So it forces AI to do test-driven development. And then after you create the constitution, there's specify. Specify allows you to create the spec file, and this spec file captures the requirement. And then, of course, it goes back and forth, right? It starts interviewing you what you actually need. It's kind of like you're doing brainstorming and creating that spec. And then after that spec, you create a plan. A plan creates the implementation strategy. It also does the research that it needs in order to create the implementation. And then after that, once you have the plan, now you start building tasks. Task breaks it down into stories, right? It breaks it down to epics. And also, what are the parallel things that you can run or you have to, an order of things. And then, now the agent can start the implementation phase, which is creating the code. But notice how you have to go through the specify, then plan, then task, before you even write the code. And in between, you can specify and you can clarify. That means after you do specification, you do clarification if there's other things that you miss. And also, when you're building the task, you can do analysis. You can do /analyze to go back and see if they're all lined up. Meaning, if the task, the plan, and specs all line up together before you even write the code. So the whole goal here is to make sure that whatever the agent is going to build all lines with the spec. So I'm going to show you a little bit of demo, what that looks like. And of course, we're not going to watch the whole 20 minutes of this, because there's a lot of them. Because it took me 20 minutes just to write a spec. And this one, I'm installing the spec kit. So once you install the spec kit into your application, into your code base, it will actually generate this .specify, and it would install the agents into that GitHub folder. And so now that's when you can have this /constitution /spec kit plan. And in this case, I'm creating this, I specify red, green, TDD, those kind of things. And then it will go through that whole process. Let's see if we can forward it more. So once it specifies the constitution, now I can start, creating the plan. So in this case, I created the spec first. I did not show this on the video, but this is the spec that I'm creating. And then now I want to create a plan out of that spec. So once you have the spec, once you have a spec, then it will create a plan. So once you have that plan, it starts to analyze the code, what is required. And also, since this is a backend, it'll create the contract that it needs. It would start researching, create the data model, the contracts, some instructions on how you would install it, those kind of things. So it'd go through each one of these. So it starts to create that plan. And then after it creates that plan, you can, now you can create the task. And this is what a task looks like. Notice how it has a checklist of all the different phases for this plan. And it also creates the stories around that implementation for that spec. And then once you have that phases created, then you can start to do that /implement. Now in this case, that's when it starts writing the code. So it starts writing each one of these code, and then as it goes through each one, it's also creating the test first, and then after it creates a test, it creates the implementation. Write again, test again, write the implementation, or write the code, and then go back and forth until it gets done. And it has a checklist of all the things that it's doing. Notice how it's showing you what the code changes are and also what it already implements. Interesting? Yes? Yeah. So notice how it's more of a grid. Notice how spec-driven technique, you write the spec first, you write the specs in code in plain English, and then you spec as the system prompt, and then if you have some failures, you have it goes back and forth and does the refactor. So when should you use spec-driven development? The verdict is For anything production features that needs compliance needs, something that's long-lived, that the team would have to maintain it, anything that you can go back and trace the decisions between the between the implementation, and of course be able to audit. The important thing is the auditing features and how the agent created the code. And of course, not everything, of course, need to be event spec-driven. And then we'll talk a little bit more about these event-driven coding agents. So this is more towards like, now I have a spec, but I want the agent to run autonomously. So today you write the prompt, you watch, does its thing, and then you get the results of the code. On the event-driven side, you create a GitHub issue, and then once you create a GitHub issue, you let Copilot run in the cloud, run its own thing, create an agent that spins up and reads whatever is in the code base, create that plan and implements it, creates a draft PR, and then now it's ready for a review. So so you can use it to assign the issue to the, in GitHub, you can assign the issue to Copilot, or you can have it to where, you can specify at Copilot or at Claude, and then you can use it to review the PR comments and all that. So first, what you can do here is you can assign the issue, then the agent would research, and then it will create that plan, implement that plan, and then you can review after that. So, of course, it's more important when you're doing this is that you have a good spec, right? You need to specify that it's not a vague issue. You need something that's agent-ready issue, meaning you've determined like what is it that it needs to implement, and then it can start implementing it. So let's look at this. I think it's an example. I know we have a few minutes left. So I have this spec, small, that has an acceptance criteria, requirements. And so what I did here was to assign it to Copilot. And once I assign it to Copilot, it starts creating an instance. Once it sees it, starts creating an instance, and it starts reading the code base itself. It starts implementing step by step of what it needs. And then after it's done, it will create a PR. So once it creates a PR ready for you, and then you can, so then you can continue on and merge it afterwards. Yeah. So you can also have Copilot to review by specifying at, Copilot, go review this, those kind of things. Okay. So when should you use each one of these, right? So if you're doing vibe coding, it's fast. Sometimes it's intuitive. When should it's fast. And then you do context engineering, and then you have spec-driven development, and then coding agents, right? So for speed, of course, it takes you longer to do spec-driven development as compared to vibe coding. For coding agents, of course, it's async. In terms of consistency, you have more consistency for spec-driven development as compared to vibe coding. Of course, context engineering, you have something that's medium to high. And then, of course, risk tolerance, governance, and all these. You have something that's formal versus, that's not there. And then, of course, for exploration, reviewing cost, artifacts, a lot of them are stated here. But of course, there's always going to be pushback, right? It's because it's harder to trust some of these AI, what they would do. Writing specs is too slow, right? So definitely it does, because but reviewing them takes longer sometimes, right? AI, code review takes longer sometimes. AI should figure out this out itself. Sometimes it's harder for AI because it's not a mind reader. It's sometimes, spec-driven development is over-engineering. Well, use vibe coding for prototypes. Spec is for something in production code. And of course, adoption. Team adoption is important, right? But starts with something simple. Start with an agent's MD. Start with creating a skill for the team. Let the team use it. So we talked about this AI adoption hierarchy. And you notice at the bottom, the upfront configuration time takes longer as you go up the level. But the implementation time takes shorter because because of the having more context for the agent to use. So 4 takeaways for this presentation. Match what the method risk is. What is the context? Context is the multiplier. The more context you can provide, the more important context that you can place it in would help. Then let agent work while you sleep. And then the last one is on any one of these, vibe coding, context engineering, and also spec-driven development, do AIM, and also TDD. You have better output if you specify that write the test first before you implement the code. So if you want the sample of what I've done today, you can feel free to get the code there and also the slides. And this is the information. And also, the best way to contact me if you have questions is through LinkedIn. I really appreciate your time, and I will be at the hall for any questions. Thank you very much, everyone. Appreciate you.